Hi, I want to bring your attention to something that we spoke of towards the end of the Chapter 3 lab sections, but I need to iterate it here. With respect to multiplying or dividing by a constant, you'll notice I have sample mean 4 here. So if you add 8 plus 6 plus 3 plus negative 1, you get 16. And take the mean of that, those 4 numbers, you get 4. Now, what if I added a constant of 10? I get 18, 16, 13, and 9. Everything just moved 10 down the number line. But I hope you'll be impressed that they did not become more spread out. The range, if you will, between 18 and 9 is roughly 9. And I say that because there's an alternate definition of the mean, or pardon me, the range, that says 18.5 to 8.5, which would be 10, but let's not split hairs right now. So I hope you'll appreciate that this did not blow them up, if you will. It didn't make them more spread out, adding a constant of 10, and it doesn't, as we illustrated before. On the other hand, down here, what I did is I multiplied everything by 10. Instead of adding a constant of 10, I multiplied it by 10. So 80, 60, 30, negative 10. And what did that do to the standard deviation? Well, heck, now I've got a huge range from negative 10 to 80. So either 90 or 91, depending on how you want to conceptualize that. Did that affect the standard deviation? Well, of course. Let's check it out. So analyze descriptive statistics descriptives. And you know what? Before I go there, let me just do the right thing once and get rid of all of the other crud I have on here from before. Great. Here we go. And I'll go analyze descriptive statistics descriptives. And this time I want to put in all the variables. So I'll put in the original sample mean 4, added a constant of 10, and then multiplied by 10. And let's see what that did to the standard deviations. Well, here we go. In this case, when I only multiply by a constant, sure enough, the variance and the standard deviation are the same. Well, that kind of makes sense because I'm only multiplying by a constant, and indeed, it only shifted them down the number line. That's all it did. Okay, well, fair enough. Now, on the other hand, what about when I multiplied by 10? How did that treat the standard deviation? And sure enough, it blew it up by a multiple of 10. When we multiply or divide by a constant, and you could argue that multiplication and division are essentially the same thing, but when you multiply by a constant, it's going to multiply that standard deviation by that constant as well as the mean. On the other hand, even though the mean is affected by a constant of 10 being added, the standard deviation isn't being affected because we're just shifting it down the number line. That's all that's happening. So I'm just moving everything together with a constant of 10, just changing addresses, if you will. Whereas this is exploding the variability, as you can just tell by looking. I can tell there's a monstrous amount of difference between negative 10 and 80 versus negative 1 and 8. That really spread things out. So it's one of those things I think you can just sort of kind of almost viscerally feel. It's there are maxims or rules in statistics, but this is one of those things that's pretty accessible.